Okay, it's getting started with Camunda Cloud and Kotlin. I'm your host, my name is Josh Wolf, and I have no idea what I'm doing, so that makes two of us, but let's just go through this together. So I'm assuming that you have the Java Virtual Machine, JDK, and an IDE installed on your machine, and we're going to go through these instructions here. So you can get started by downloading a Maven Spring Starter from this website. Here's one we prepared earlier. So all you need to do is click on Generate. It's going to download the zip file. I'll open that up. And now we're going to extract the contents. So it's got a Cloud Starter folder in here. Click here. No, stop. We want to extract it to somewhere else. Nope. Stop. There's a way where I can extract it to a specific folder. If I click that and then go hold. Yeah. Other folder. There we go. Beautiful. So we're going to put it into workspace. I got this Camunda and I got a scratch area that I use for doing this kind of stuff. Extract here. Here we go. That was quick and easy once I figured out which button to click. So if I ls in here, Cloud Starter. Let's cd into there. Now I'm using IntelliJ Community Edition. Great IDE. Love it. So I can just type in idea dot, which will open. Okay. Didn't quite open the one that I was looking for. I think because I already had the IDE open in that kind of wizard dialog there. Good. So here we go. Here is our project, Cloud Starter. So let's have a look at what we got here. Now, the next thing that we're going to do is we're going to install the ZB Spring dependency into the pom.xml. So we're using ZB Spring. And so it's going to be a Spring application. Spring really makes it easy to build ZB applications, and you can do it with Java or with Kotlin. So if we go back to our instructions here, we've got the dependency that we need. It's IOZB Spring, Spring ZB Starter, 0230. So we'll drop that into the dependencies as a dependency. And let's save that. Bam! Maven. Let's have a look at the dependencies here, and if we just synchronize those dependencies, resolves them, downloads the missing dependencies that we need, adds them to the project, and we should see IOZB Spring, there it is there, here, magically. That was easy. Okay, so having done that, we're going to log into Camunda.io. This is Camunda Cloud. It's a hosted ZB broker in the cloud with an operate instance for visualizing your workflows. Now, if you don't already have a Camunda Cloud account, you can open one by going to Camunda.io and it will redirect you. I'm already logged in here. It's going to take us into the console. Now, let's delete this Spring Starter cluster. These clusters are all running in Europe West 1D, which is Google's data center in Belgium. So depending on where in the world you're connecting from, you're going to get a different amount of latency. If you're in Europe, it's going to be like super fast. If you're somewhere further away, it's going to be a little bit slower. Waiting. There we go. Okay, so I want to delete this cluster, so I'm going to walk you through creating a cluster. Let's go back to the playground. The cluster is still there. Did I click the right thing? Delete cluster. Pay more attention. Delete. Okay, I definitely clicked it. It definitely deleted it. Great, so we click on Create New Cluster. Development, free beta, ZB 0233. Let's give the cluster a name. We're going to call this one Spring Starter. Make it both caps, Pascal case, I think that's cool. Okay, seconds later, bam, there it is. It's got a red dot there, it says creating. Now, while that one is baking, Kubernetes is deploying the pods and everything, we can go into clients and we can create a new client. This is kind of like an API key for accessing your cluster programmatically. So here we'll just call it, I don't know, Cloud Starter, hey? Cloud Starter, like that. Add. Now when I add this client, I get these connection credentials here. So I can click on connection information, gives me all the things that I need. So I copy that. Now, let's go back to the IDE. We're going to put those credentials into source, main, resources, application.properties, right? We're going to drop them in there. Now we do need to change some things here because these are like bash environmental variables. Let's get rid of export for starters, right? The next thing we need to do is, that was interesting. Okay, get rid of that. This last line we do not need, so we can delete that whole line. And then we're going to take off the apostrophes. Do not need apostrophes in application.properties. Delete. And that thing got added on, so we'll take that off. Now we do also need to change the keys for these because these are the bash environmental variables. Luckily, we have the keys here. So this first one is ZB Client Cloud Cluster ID. So we'll paste that there, and then we also need to take off this because this is the like fully qualified domain name and port. So we'll take that off. We just need the UUID of the cluster, the client ID, which is kind of like the API key for accessing it, and the client secret, which is the other part of the API key. There we go. Beautiful. Just like that. Okay, next, we're going to test the connection with Camunda Cloud. So let's go into the main class. So it's in source main Kotlin IO Camunda Cloud Starter application. So the first thing we're going to do here is we're going to annotate our class as a ZB application. Give it a second. Unresolved. Nope, is that the right one? Enable ZB client. What was I thinking? Obviously of the wrong thing. There we go. So I can go command dot, control dot. Yeah, import. There we go. So we've now enabled a ZB client. Now we want to auto wire a reference to the ZB client in there. So we can just drop this in as a property of the class, and let's import all of the missing references, hey? Import that one, and then the ZB client lifecycle, let's also import that, like that. Okay, now that we've done that, we're going to trigger our operations for this application via REST. It's really easy to make a REST application in Spring, as you probably know if you're a Spring developer already. So we just annotate the class with REST controller. We need to import that, so control dot. Now that we've done that, we're going to create a mapping. It's a GET mapping, so it's like a handler for a GET request. Import. So we've created a REST route, HTTP GET on status, and what it does is it uses the injected client reference, calls the new topology request method. So it's creating a new topology request, which is kind of like a status request, requesting the broker, like, what's your topology? And then we send the request, and then we call join on that to make it synchronous. Otherwise, it's going to return a future, but when we call join on it, makes it synchronous. And then we call the toString method on there, return it from the controller, and then that'll return that value to the requesting caller. So that is all I need to do to get myself with a cluster and to connect to it. So let's just make sure that this has finished provisioning. Pretty sure that it has, but we'll just check for the sake of completeness. No, it's still creating. Okay. Lucky I didn't try to run that then, because if I had, I would have got an error. Now, you might have noticed there that it said that my other two clusters have gone unhealthy. Now what this means is that these clusters, they're single nodes. This one is not a single node, this one's actually replicated, but what's happening here is that the pods are rescheduling. So with the replicated cluster in the current open beta of Camunda Cloud, they're all running on preemptible nodes, and the gateway for this cluster is being rescheduled right now. These ones here, there's a single node cluster which has an embedded gateway running in it. So that single node is being rescheduled, and the replicated cluster, at least the gateway, is being rescheduled right now. So you will experience during the beta moments where you'll get an HTTP 503 status unavailable response when you try to connect to the cluster programmatically, and that's a temporary kind of condition that goes away and comes back. It's one of the 5 fallacies of distributed computing, that the network is reliable. It is not. So you've got to build resilient applications that take that into account. Okay, so yeah, we'll just leave it for a second. What we might do in the meantime is let's run the application just to make sure that it does compile and that it can start. Interested to see how long it takes to start. My Java application took between 9 and 12 seconds to start, and then when I did this, I rebooted my machine because it was taking 1 minute and 10 seconds to start. 3.977 seconds. That's pretty good. 4 seconds to start. Let's have a look. Spring Starter is healthy, it's back up. So what that means is that we should be able to go to localhost 8080 and then hit the status endpoint. Okay, no, that did not work. So let's check what went wrong. Okay, we enabled the ZB client, the REST controller. We've got a get mapping on there for /status. Yep. Started on port 8080. Yes. Okay. Let's try it again. Status 404. Okay, let me go back to the documentation. So 80% of all programming is debugging. The other 50% is choosing the right names. Let's have a look. Okay, it's a class. Yeah, okay, I'm missing. Wow. Okay, I'm missing braces around this thing. Done. Wow. Okay, so let's restart the application. So finished, restart. 4 seconds to compile. Let's see if it can beat 3.977 seconds this time. Agents. That's longer than 4 seconds, so it must be measuring from 3.398 seconds. Okay, let's try hitting that status endpoint again. And this time, there we go. So this is the topology response from the broker cluster. In this case, it's a single broker, right? So it says brokers, it's an array of brokers in here. Node ID 1, so there's Node ID 0, so there's one broker, fully qualified domain name for the Kubernetes resolution. And here's the version, 0.23.3, one petition, cluster size 1, petition count 1, replication 1, gateway version, etc., etc. Okay, so the status, we're up and running, we've connected to it. Good. So the next thing we're going to do is we're going to create a BPMN model. So to do that, we're going to use the ZB modeler. So the ZB modeler you can download from GitHub. The ZB modeler releases page here, 091 is the latest release at the time that I'm making this video. And you can see there are different versions for different operating systems, Linux, x86, 64, Mac, and Windows 32 and 64-bit. So I've already downloaded it. So I'm just going to go ahead and open my copy of the ZB modeler. Comes. Great. So we are going to create a BPMN diagram. We're going to follow these instructions here. So we're going to add a task. Let's make this a little bit bigger for your viewing pleasure. And an end event. So let's give them some names because it's best practice to do that. Okay. So the whole thing about BPMN is that it's human readable. So with the service task here, we click on this little wrench/spanner icon and choose service task. Now we pop out the properties panel here, and the name, unfortunately I can't make this any bigger, we're going to call it get time. Now the type is get-time. Now the task type, is kind of like a topic or a subscription kind of ID. That's how your workers are going to subscribe to that work for that task. So that's important there. So we're using get-time. Okay, now here we're going to call, so you got name and ID, right? So name is going to be called test process. It's a human readable name, this one. And then the ID is the kind of unique ID that we use to start instances of this process. Okay, to get to this part here, I just clicked on a blank part of the canvas. So these are the properties for the entire diagram itself. These are the properties for that task, that's the property for the end event, etc., etc. So now we're going to save it. and we're going to save it to workspace, Camunda, it's in Scratch, Cloud Starter. Now we're going to put it into source main resources, and we're going to call it test dash process. Doesn't have to have, these are all arbitrary names. I've just used the same name for the, I do it like this, I use the same name for the process ID and for the file name. It just makes it easier for me to correlate them when I'm looking around for stuff. Okay, we've created our first model in BPMN. That's pretty easy, huh? Now the next thing that we're going to do is we are going to deploy that model to the cluster in Camunda Cloud. It's so easy to do this, real easy. To do that, all we need to do is we need to annotate this class at deploy resources, ZB deployment. There we go. And we have to give it like a class path resources. Here we go. Like that. It's an array of models that we wish to deploy. So I'll just save that. Now, when I run my application again, when it starts, it's just going to automatically deploy that process into ZB. But there's not really going to be much for me to see from that. So, well, let's try it and see. Eh? I think you do get like some console kind of level output. Run it again. Let's take a look. Let's discover this together. Eh? Most of my programming on ZB I personally do in Node.js, JavaScript. Whenever I am coding on the JVM, I do like to use Kotlin because it kind of feels like a JavaScript on the JVM. So you can see here deployment, ZB deployment value, class path resources, it got deployed. Okay, good. Now the next thing we're going to do is we're going to create and start a workflow instance. Now to do that, we're going to create another REST mapping for the start route. So if we go down here and we just add this. Now what we're doing here is we are referring to the the injected reference to the client, a new create instance command, and then we use a builder pattern in Java and Kotlin. So you got the BPMN process ID, that's test process, the latest version, send the command, join it so that we get like a synchronous response which we assign to workflow instance event, and then we call to string and return that to the caller. So let's see what happens when we run this and then hit the start endpoint. So we're going to rebuild the application, restart it. So the last one was 3.3 seconds. Let's see if it's faster or slower this time. Deployment. I think it will be slower because it has to do the deployment. 6.448 seconds. Okay, now if we go to our localhost 8080, and this time we call the start, do a get request to start, and we got back a create workflow instance response. So we got a workflow key. Here's the BPMN process ID of the process that was started, the version, and then a workflow instance key. So this workflow key is the workflow definition. Now, to see the running instance of our workflow, we can go back to Camunda Cloud Console, go into the Spring Starter cluster, a cluster where we started this instance. Now, on this overview page here, you've got workflow instances, and you've got a link here, view and operate. Operate is the visualization component for ZB. I click on view and operate, it's going to open the operate UI. So the way it works is that the broker is doing its thing and it's emitting, exporting events which go into Elasticsearch, and then operate reads the Elasticsearch and then generates the running state out of Elasticsearch. So you can see here that we have one running instance in total, instances by workflow, that's a workflow definition. We have test process, that's the human readable name there. Let's click on that to go in. See here is, this is an aggregate view. If we had more processes running, we'd be able to see where all of them were. Let's go into this one specific instance. You can see here that this workflow started and it stopped at the get time task. So there is a job of type, the get time task type, waiting to be serviced by a worker, but at the moment there are no workers. So the next thing we're going to do is we're going to create a worker to service the get time task. Now that's pretty easy to do. All we need to do is add another method with an annotation, and the annotation is the @ZBWorker annotation, and then the type here is the task type that this worker will serve. So this worker is going to poll the broker continuously, and it uses long polling, like about, I think 60 seconds is the default. You can configure that. But it asks, are there any jobs of get time type waiting? And then when there are some, the broker will stream them back to the worker, and then the worker will invoke this handler for each of the jobs, and that'll get passed a reference to the client and also the job, which is like the data and metadata. So what we're going to do is we are going to log that out to see what it looks like. So the first thing we do is we're going to add a reference to a logger in here. So let's drop that in here. Okay, so import these things. That one, yep. Logger, yes. Okay, so we're going to create our worker. Copy and paste. Probably the greatest innovation humanity came up with since like opposable thumbs or sliced bread. So again, we'll just import all these missing pieces. API response, job client import, and then import the ZBWorker annotation. Okay. Now, we're going to stop the application and restart it. Now, when we restart the application, it's going to deploy the model, and it's idempotent, so it's not going to create a new version because we haven't changed anything in the model. Then it's going to start that worker, and that worker is immediately going to service the task because we know there's a task waiting for it. Let's run. And then when it services that task, it's going to log out the job data that gets passed in here, and that'll give you a sense of what is the data that the job workers actually receive when they get a job from the broker. Did not work. Let's have a look. 80% of programming is debugging. Application run, visualization. Okay, we're missing the ZB client worker default name in application properties. Okay, right. Yeah, no problem. So if we go into resources, application properties, we'll drop it in there. Default name equals worker. So you actually have to have that in there. I'm not sure why, because I don't have a default worker, but it would be good if the default worker default had a default. Default worker name. If it did itself have a default. I might open that as a feature request actually. Okay, 4.91 seconds to start, and then you see here activated 1 jobs for worker, and job type get time. Now here's the data. This is the shape of the activated job that comes in. It's got a key, it's got the type, it's got like custom headers if there are any, workflow instance key, BPMN process ID, definition, version, element ID, instance key, retries, deadline. And then this is really the interesting one here, variables and variables map, which is the payload of the workflow at that time. And then what we've done here is we've called a new complete command. And then what this does is we can complete the job, we can fail the job, or we can throw an error. And these are all, responses to the broker to let it know how it should handle the outcome from the worker. And then we have to pass in the key of the job, so we just get the key. If you have a look down here, you see the key here. This is what uniquely identifies this particular job and correlates back to that workflow instance, and then we send that, and then we join it. Okay, great. So the next thing that we're going to do is we are going to create and await the outcome of a workflow instance. So we created a workflow instance earlier, and what we got back was a reference to the workflow instance, but we didn't get the result of the workflow instance. Getting the result of the workflow instance, you could do it through the exporter, or you could put some kind of like task at the end of your workflow. But the other way you can do it is you can tell the broker to start a workflow instance, and your command will wait until the workflow instance has finished or it times out. By default it's 15 seconds, and then it'll get the result of the workflow back, and you can expand that time from 15 seconds to more if you need to. But this takes like seconds to finish, so we don't need that. So what we do to do that is, instead of getting back a that does not look correct, actually. Yeah, okay. Let's just grab it and I'll fix it. Yeah, so you can see here we do a create instance command, and the only difference really is that we do with result. So when I say that it doesn't look right to me, 80% of programming is debugging, and the other 50% is correctly naming things. And this has got the same name as the last one, but this is not a workflow instance event. This is a workflow instance event with result. So here also with result. Yes, that is correct. Okay, good. So let's stop the program and then rebuild it and rerun it. So this time when we hit our start endpoint and create an instance of the workflow, what we're going to see in the browser is no longer what we saw previously, which is the create workflow instance response. We're going to see a create workflow instance with result response, which has not just kind of like the starting information, but has the complete workflow. Let's try it. Okay, here it is, create workflow instance with result. You can see it looks pretty much the same, but the key difference here is that we have the final variable payload of the workflow, which is what you're really interested in if you're waiting for the outcome of a workflow. But it's not a very useful workflow at the moment because it doesn't do anything. But what we can do is we can modify our worker and we can call a REST service from the worker. So it's going to reach out over REST, and I've got an API that you can use here, JSON-API.joshwolf.com/time, that just returns the current time in GMT as a JSON object. So let's grab this whole thing here and drop it into our getTime worker. Bam! So what we do here is we log out the job again, and then here's the URI that we're going to be requesting. We use REST template, which is part of the Spring framework. We do a get, and then what we do here is we do the complete command, but this time using the builder pattern, we add the variables and we put the result from the REST call into the workflow payload under the time key. Now this is a string in here, and it's actually stringified JSON. So the workflow payload it's kind of a JSON object, but it's stringified JSON. So handcrafted, artisanally made JSON here. Okay, do I have the right number? I do not. I've got too many braces. Save that, and then let's restart the application. So this time we're going to run the application again. We're going to start a new instance of the workflow, and what will differ this time is the final variable payload that we get back should include the time that was retrieved over REST by the worker for the getTime task. It started, so let's create another workflow instance. Here it goes, and there we go. It comes back and you see this time the variables payload has been populated. Time, that's a complete string here, and we've got the hour, the minutes, the seconds, the days, the month, and the year. There you go. So we called a REST endpoint from inside a worker, enriched the payload, updated the payload, sent it back to the broker. Now what we're going to do is we're going to make a decision based on some aspect of the payload. So if I go back to my ZB modeler, we're going to modify our diagram here. And what we're going to do is I'm going to break this link, And from getTime, we're going to add an exclusive gateway, decisioning gateway. And then from there, we're going to add a couple of tasks. Let's make them symmetrical. Like that. Good. And then from there, we flow to the end. Boom. Let's keep it symmetrical, hey? Okay, great. So we're going to click on the little wrench here, change them to service tasks, yeah? Now, this is going to be, so the decision point that we're going to make here is we're going to branch on whether it's before or after midday. That's how we're going to branch. And then what we're going to do is we're going to make a greeting. This is basically a Hello World enterprise distributed Hello World application. So this first one here, up the top, the name is going to be before noon. So this one happens before noon. And the type of this task is going to be called make greeting. And this one down here is going to be afternoon. And it's also going to be of type make greeting. We're going to specialize the behavior of these two tasks, even though the same worker will service them by using a custom header. So to do the custom header, we go into headers. We're going to add a header here. The key is greeting. And then before noon, we're going to say good morning. Good morning. This one here, add a header, greeting. And this one is good afternoon. Yes. Okay. Now to, that's not quite symmetrical. Let's have a look at that. Is that symmetrical? If only it had like alignment and distribution.
Any other questions?
Anyways, what we do here is, so we're going to put a condition on these branches, right? So you've got a condition expression in here, and this uses feel, which is the friendly enough expression language. Now, if you have a look at the documentation here, you can see here's the expression that we're going to use. So we're examining the payload, and we're taking the time key off the payload, and we're taking the hour subkey off that key. And then we're saying if it's greater than or equal to 0 and the time.hour is less than or equal to 12, take this branch. So drop that as a condition there in the condition expression. And then what we should do as best practice here is we put, well, different people do it different ways. You could put the actual thing, but yeah, you know, you do time.hour, so we can say, but we'll just put like here, we'll say is before noon. And then we put this, let's put it there. Now, here we could try to make some exhaustive condition, but what we can do, which is real easy, is we just click on the little spanner and choose default flow. So it's kind of like a case statement in that, you know, if this condition is met, it'll take this pathway, and if this condition is not met, it'll take the other pathway. Simple, right? So here we'll say afternoon. Is afternoon, so we should say is afternoon, like that. And then to make it symmetrical, put that down here. There we go. Okay, so now what we have is we start the workflow. Our getTime worker will get the current time over rest, and it will get to the decisioning gateway. Then it will, if it's before noon, it'll take this branch. If it's afternoon, it'll take this branch. Now, if it's before noon, it takes this branch, and then the make greeting worker will get a job of type make greeting. And what makes these two tasks different is that the custom header differs. Same worker, different custom headers. Okay, so now I'm going to save that, and we're going to implement this make greeting worker. So let's go back into here, and we'll just cut and paste. It's the easiest way to get this done. Cut and paste. Okay, the make greeting worker. Yes. Paste. There we go. So the make greeting worker, it grabs the headers from the job custom headers, and then it pulls the greeting out of the custom headers. And I use get or default here, you know, in case there's something gone wrong with the model. It's a default good day. Then it grabs the variables as a map, and then same thing, get all default, and we pull the name out of the variable. So we want to start the workflow. Here we go. Is this an HTTP 503? No. Sometimes you get these gRPC kind of like jittering or network kind of effects like that. But it's resilient. It'll just keep plugging away. So yeah, so we get the name out of the workflow. So when we start the workflow, we want to actually put a name into the workflow. And then what we do is we create a templated string, the greeting plus the name, and then we update the variables with a new key called say, and we punch it into there. So let's go back up to where we start our workflow instance, and what we want to do in here is we're just going to add variables, right? And for the variables, we're going to say name, and we'll use my name, hey? My name is Josh Wolf. There we go. Handcrafted. Oh, my name's not even in the dictionary. Anyway, whatever. More actions. Save it. Okay. So this is again handcrafted JSON stringified JSON object. Stringified JSON object. Handcrafted. Save that. We're going to return the entire thing here, but one thing that we can do is, rather than returning the whole string, let's return the whole string and see what it looks like, okay? And then we'll do the next step where we just pull the say key off the variable payload. We can use get or default variables. Yeah, see, we can call variables as map, get or default say, like that. But what we'll do is we'll just run one through. Okay, so we'll start an instance. Okay, I broke something. 80% of programming is debugging. Unexpected end of input. Okay, I've done something wrong here. Let's have a look. Name. Yes. Okay, I forgot to close in my handcrafted JSON. I forgot to close the object. It's one of the things that I like about programming in JavaScript is like it speaks native JSON. So, I mean, in Kotlin this is a string. There may be a way to get type-safe JSON, or at least syntactically valid JSON in Kotlin. Okay, started. So let's run this one. Starts an event. It's doing its thing, and here we got the result back. And you can see here that it's created a new say key, and it's put "Good morning, Josh Wolf," because time is in fact Monday, 6th July 2020 at 12:59 GMT. 12:59. Should that be good morning? I don't think that should be good morning. Oh, okay. Wow. Yeah, my logic is faulty. Dude. Yeah. Time is less than or equal to 12. So it should be less than or equal to 11. That's good to know. Save that. Okay, let's do two things at once. Well, it's about to tick over to 1 anyway, so we're going to miss it. Okay, it's good to catch that though. Okay, so programming 80% debugging, 50% finding the right names, and then 20% fixing logic errors. Off by 1 errors. The two most important things in programming: debugging, getting the correct name, and fixing off by 1 errors. Okay, so let's okay, so instead of string, let's do get variables as map. Variables as map. And then we can do get or default. Get or default. Oh, it doesn't like that. Mutable string cannot be invoked as a function. It's a property. Yeah. Get or default. And so we're going to get the say. and our default is we will say error, no message, no greeting found. Rather than say, I should probably have used greeting. Speaking of using the right names, save that in an auto format. Nope. So let's do this to make it look a little bit better. There we go. Nice. Okay, let's run that. Doing its thing. Okay. Wonder how long this one's going to take to start. I think it actually starts counting from the time that it shows this thing here, spring, so the compilation time is not included, 6.34 seconds. Okay, start a new workflow instance, gets the time, does the calculation, creates the greeting, and boom, good afternoon, Josh Wolf. Like magic, it's a hello world example. Let's go back to operate and take a look at the running instances. Now, there is one running instance. Why is there a running instance? There should not be a running instance. It's not. It's gone. So one of the things about the exporter and the Elasticsearch and then operate looking into the Elasticsearch is there is some latency on the running state of the system. Just to refresh on here. And we should have 0 running instances. 0 running instances. There we go. Okay, so one thing I'll show you now is that if I go into running instances, I can find the finished instances here. The last one we ran is version 3, and we can see here's the whole pathway that it took. Final variable payload, and then we've extracted that, got it in our program. So there you have it. This is how you can create a a Spring ZB application with Kotlin, and you can create a model, deploy it into the broker. You've got like a decisioning gateway, you've got a couple of different workers, you've got one worker that reaches out over REST, updates the payload, and then here you've got specialization of a worker based on custom headers. Pretty easy to get up and running with Camunda Cloud, and if you go through the ZB documentation, there are the forums, the ZB forums, the ZB Slack, a bunch of different kind of resources that you can look at. You can even just go through the API itself, to discover more stuff about it. So there you go, getting started with Camunda Cloud, Spring, and